Let's make this first. Cassette for a second. She might not like you calling her a loser. Cheaper? Same price. Try those. So how are you critters doing today? Are you being good critters? Oh, you lucky bastard. I'd really love to have a U1. Ooh. Now that's what if I had to pick one or the other, I'd obviously be index. That's amazing. Beginning a conversion or an entire printer? Yeah, I bet. Boy, oh boy, yeah, something I feared when I made the mount joint. It cracked. Should have known that was gonna. Especially because I made a big mistake where I made a point. I had it come to a point right there. That's obviously a stress point. As soon as I applied stress to it, it just cracked. So there's an easier way I'm gonna do. Hey, I'm gonna make it a half and half with 2 screws, one on each side, and then I was trying to overcomplicate it to save on screws, so it'd be only plastic. Hey, Cyber Bob. So there's 2 ways I can do that. The actually wouldn't be that hard to make a sleeve. That wouldn't be that hard at all. Just skinny up the neck on one side and stick them together. That would work. I could also make it a half and half like this. You have 2 screws and you gloop it together. And once the gloop sets, you can take the screws out and you can reuse the screws. That's an interesting idea. Yeah, I overcomplicate it. Oh, that's just the joint. Yeah, time to simplify it. I thought the flange for the screw would be enough to hold down the edge. Yeah, plastic just moved around it. I also got the speaker in. This is the little Philips BT55. You can get these for $6 on AliExpress. Super simple. It's just an on-off button. It's micro USB, but I don't care because ripping out the battery, powering it off of one, basically. So basically, I'm going to design a mount so this will be integrated into it like that. So it'll just be a simple Bluetooth speaker that will run for days and days and days and days and days. Probably got a sub 2,000 milliamp hour battery in there, and it goes for 6 hours. So if I have 10 times the battery, it's 10 times the runtime. It's not. It's decent. The sound quality is actually surprisingly good for such a cheap speaker. The volume is not quite what I want. Not bad, and some songs and some programs sound great. But then again, you have some songs that like what? They're just not normalized. Um, I could fix that in post by normalizing all my stuff, but most of the stuff like audiobooks and podcasts play fine. It's kind of what I want it for, because I also plan to make a version with a beefier speaker. Like I'd like to get one of those, outdoor or whatever, 60-watt bigger ones, and just gut it and put 2 big batteries in there. The idea is just to be able to run a really, really long time, and also to not have to replace it because the battery wears out. Because that's the problem. You spend $100 on a nice speaker, and then in 4 or 5 years it's shit because the battery's puking. So if I can make it, number one, a replaceable battery, and number two, a big high cycle life battery like lithium iron phosphate, um, that removes that disposability of the unit. Oh, I got more liquid poison this week at the Roadrunner. Yeah. I got 4 more gallons of extra sweet tea. This stuff is so evil. It's so bad for me. But I'm not turning down 4 gallons of free sweet tea. I've I already drank about 10% of 3 different gallons, and now they're in the freezer turning into solid blocks. You have to keep it refrigerated. It's not the kind that it's not shelf stable. I found out that if I drink it down to about here, then it doesn't pop the bottle when it freezes. Um, but I also found out you cannot drink it while it's frozen. Well, obviously, you can't. What I mean is, it has to completely thaw before you can drink it because the tea thaws before the water does. So what it is the more it's frozen, the more concentrated the tea is. You might think that's great, it's going to taste incredible until the rest of it melts and it's all watered down because you drank all the tea. But a gallon of tea, well, almost a gallon, 70% of a gallon, 80% of a gallon, um, once it's frozen solid to -20, like it's still not fully frozen solid last night. It takes a long time to freeze, 24 pounds of water. The Once it's frozen solid, it takes about 35 hours to thaw. So that's this is a trick we used to use with coolers. And now if you need true refrigeration temperatures, yeah. um the the trick we used to use with our coolers is that we would freeze gallon jugs of water, and we would put 3 or 4 gallon jugs of water in the cooler. So now not only did the rest of your stuff not get soggy from melted ice water, but that would keep, refrigerator temperatures in your cooler for 3 or 4 days, 4 or 5 days sometimes. So that's a neat trick. Just make sure you only fill it up to about here. Remember, water expands by 10% when it freezes. Yeah, that works great. And I have limited freezer space, so this will allow me to freeze it, and then I can leave it out of the freezer for 2 days and not have to worry about it getting too warm. One problem I'm having with this, I've only played with it a little bit, I can't figure out how to take it apart. There's no screw holes. I already pulled off one of the pads. There's no screw holes underneath. This is just pressed fit together. It's snapped. You tell there's a bottom and a top, and then you got these 2 halves of the shell. And this is the kind of thing where you have to be really, really freaking careful, because when you're sticking a spudger or something in here, it is so easy to slip. Then you slice the shit out of yourself, like hospital kind of slice the shit out of yourself. So you really, really got to be careful when you're trying to take things like this apart. Ooh, also I got another one of these in from AliExpress, the little micro ones. Got the red ones in. I like the I'm going to avoid the yellow ones because the yellow ones don't have the locking thing like the reality ones do, like these do. I really like that little locking thing. I don't care if I'm destructive with it. Yes. Yeah, you could definitely see it moving. There we go. See, I got it in there. Got it in there now. Now the trick is to get the snaps to come up. I think once I get it in there, shove it in there, now I should be able to go in there with some other tool. Be very, very careful with these. I have snapped these arms off, these 2 teeth here. I have snapped them off. Right? And when those snap, they're projectiles. It's like a bullet. I've embedded it in a wall. Like, snap. Now imagine in your eyeball, okay? Be very careful, please. So I hope, be able to just work it along here. Get the snaps to pop open. I bet you if I just do it from both ends. Yeah, there we go. It's popping. Yeah, see? You can see it right in there. There's a little snap right there. There, where it latches in place. Trick is to stop it from relatching as you try to unlatch it. Okay. Are unlatched. Okay, those 3 are unlatched. Right. So that means there must be latches along here because it's not popping open. Trick is to not push with too much force. Stressing it right here. You can see the plastic is stressing right there. See that white line? I can get under here and pop it. There we go. It's working. It's shrinking! The planet's shrinking! Who can remember that scene? There we go. It popped apart. And now I have screws. Okay. So the front fascia comes off, and then there's 4 screws inside there. Okay. Come on, someone's got to remember what movie that's from. You guys don't know what movie that's from? Really? "2010 Space Odyssey 2? And Jupiter starts to shrink, and what was it, the Lemonov? Name of the ship? Something like that. They used Discovery as a booster to get out of the way of the blast radius, where the aliens turn the Jupiter into a star. These worlds are yours to do with as you please, except Europa attempt no landing there. There we go. Back pops off. Oh, interesting. Okay. Wait a minute. What is that? What is that? Oh, that's the button and the micro USB port. Oh, it comes with a nice long tether. So you can actually open the thing up. Wasn't that interesting? I wonder if it needs the... Oh my... You gotta be kidding me. You've gotta be... That's the battery? No. Well, actually, this is sealed. So that means it must be using this as a passive audio chamber. Which means it is going to be important that I reseal this again. I can't just gut this. Got to be kidding me. That's the freaking battery? Hang on, I'll show you as soon as I get it back in there. Look. I think that little thing right there is the battery. That itty bitty little thing right there is the battery. Oh, come on. Could have put a 14500 in there. Cheap bastards. Oh my god. That is such a small battery. Boy, I see. Now, see, this is the difference between... Did that come out? Yes. Good, I can disconnect that. That's the difference between major players and cheap knockoff stuff. This is how I know this is made by Philips. They went to the effort to put a rubber seal all the way around this entire chamber where the speaker is located. That's because a lot of your sound quality comes from the volume, size, and how the sound is able to escape or not escape, so that it projects the sound this way instead of wasting energy pumping air out of the rest of the speaker. And then they even go so far as to put a rubber thing on the back here, so that when this pushes on it, it doesn't vibrate against it. And then even the battery is wrapped in foam, so it doesn't jiggle around and make noise inside there. That's the difference between a major player, you know, a refined product, and oh, and the shell is literally just 3 pieces. Okay. So you have this piece of the shell and this piece of the shell. Then this has snaps. Looks like 3 on each side, 2 on the top and bottom. Cyber Bob, there you are. Stop. Now, how do I get that battery out of there without breaking it? They're pretty tight. I don't know, there it's coming. Coming out. And the other nice thing is it looks like the battery is a plug, although it's under the rubber seal thing. But that actually makes sense. So it's probably going to be this little 2-pin one. unless that's the microphone, but I don't think so. Yipper, he's a good boy. Okay, that is not it. This one is battery. Yeah. Alright, so the 3-pin plug, but it only has 2 wires in it. That's your battery. That itty bitty freaking thing is the battery. Wow. Plug this back in. I have no idea what this is. Unless that's the speaker. I think the speaker is mounted directly to the board. I want to get this seal installed. If they went through the effort to put that seal there, probably pretty important. Certainly you're not going to waste their money putting it there if it's not needed. Boy, any possible place where this could vibrate and make noise, they took care of. That shows some actual thought went into this. That's something you just never see in the Chinese products. Even though, guess where this was made? China, almost certainly. In fact, it's all in Chinese, I think. Yeah, it's got the CCC rating from China. So now what I need to do is to basically take this pigtail, lengthen it, and this is going to go to the output port on my BMS. And then my BMS will have its own USB port. And I'll basically take some hot glue, fill in that micro USB port there so that it can't be used. I'll have my own dedicated USB-C port that goes to the BMS to recharge the big battery. I cannot believe how small this battery is. This is amazing. I want to see how this can't be more than 300 or 400 milliamps, if that. Really? Play with me like 365 milliamps. I'm pretty sure this said it has a 6-hour runtime. What does that equal? That's 55 times the runtime by 24. It won't be very loud, but it'll run for almost 14 days. So this battery will run this speaker for 14 days. Oh my god. Wow. That's so little power that I wonder if I could put a little tiny solar panel on the top of this thing and just ambient light would be enough to keep it running forever. Wow. Did I do that wrong, the math? Is that really small? It says 365 milliamps. That's 20,000 milliamps. 20,000 divided by 165. 54.8. Divided by 24. Oh, I did it wrong. 2.3 days. That sounds more reasonable. How did I come up with 13.75? Have a history? Yes. How did I? Where is the 13.75? It's like it's gone. That makes more sense though. So over 2 days it'll run on that battery, which is awesome. Yeah, the 14 sounded fantastical. Okay. Now the question is, am I going to need a boost converter? Will this run off 3 volts, or do I need to put a boost converter in there, bump up the voltage to 4 volts? Because it's expecting, it's going to be expecting 4 volts coming out of this. Because this is a 3.7 volt battery, but my nominal voltage is 3.65. So there's it run down as low as 2.5. If I want to get the full capacity of that battery. I don't have to worry about the speaker draining it too much because it'll be running through a BMS. So the BMS will cut it off at 2.5 volts like it's supposed to. Such a small battery. I cannot believe that that whole speaker, this little tiny thing right here is the battery. That's why not quadruple the battery and say 24-hour runtime? Why not? Or hell, double the battery and say 12-hour runtime. You got the space. Jeez. That's incredible. Very well designed, though. That's the LED. Tooth antenna. That little board does all of this. That's amazing. Sadly, this is too old to do TWS. That would be nice if this could do TWS. Because having 2 of these, that would be perfect. Okay. That out. Do. Okay, I can put this back together. It's that's right. Push in right. Could have brought the other one in. I really don't want to snap this together again. But I need to. Do I have it upside down? I think I have it upside down. I don't want to. Don't want to snap in. I have it upside down. Great. Man, did they make this hard to pull apart. Oh, I see. Side. So I know an easy solution to that. I'm going to snip off the teeth on the top and bottom. Just use the sides. This way, I can take it apart at will without fighting with it. So, there. Now that doesn't engage at all. How do I know? Does it matter? Centered. That looks centered. Shouldn't matter. Oh, it does matter. Okay. Yeah. Big, small, big, small. There is a top and a bottom. There we go. Now I just need to pop these to open it because I got rid of the pegs on this side. Okay. But I need it together so that we can take measurements. So we can model it in Tinkercad. Well, I did find a metal version of this that takes 2032s and has the big screens, like $23. So it is available. Are 35 millimeters by 85 millimeters by 75. So 75, 85, 35. Up a little bit. Let's go open it. Oh, switch screens. You guys can see what I'm doing. 8, 3. Okay. 35. 5. Why would you do that? $75. Righty. Actually, a little tight. 5.2 width. 85.2. Let's go 0.3. Let's go 0.4. I'm going to oversize it by a hair. Oh, screw that. 6 by 76. Okay. Width 34.9. We're okay at 35. I think I will make it just a hair bigger. No, because I want to cut out the front. So if that's 35, should be able to do this. Let's increase the number of sides. 6. See, why is it doing that? Why is it 19.99 and 20? That's annoying. A little taller. Locate. Okay. Now, if we take this as a joined pair, 8, take this, duplicate, shrink this by 35. So it's going to be 81, 51, 1 millimeter. Now I should be able to center these. Get a perfect lineup. That is not what I told you to do. You are supposed to be a joined pair. Why aren't you joined? These never got joined? Huh. You saw me click that, right? I told it to join these. Weird. There and there. Those are a perfect pair. 6. That should be approximately is that not fully joined? What's this line? There it goes. Now the problem is it's also curved on the top and bottom. So the question is, can I get a similar effect by using this tool? No. I can get close. But it's kind of messing it up pretty badly. The top and bottom does not have that much of a curve. Oh, yeah. Wait a minute. I forgot. The height is 76. Width is 86. Forgot you have to do it in you don't do it in here, it's distorted massively. Now let's see what happens. There we go. So I can get pretty close. This is wrong. So if I want to correct that, how can I trick it? I think if I make the height 30, then extend it here 76, that'll compress the artifacts. Okay, compressed it the wrong way. Huh? So let's make this 150. Now let's compress it 76. There we go. I think I need to go higher. Let's go 200. Let's go 400. Oh, maximum 200, huh? That's annoying. 6. But we're getting closer, though. I'll need this now. That's not a bad. It's not great. It's not horrible, but it's not great. Would adjust the steps. Not really. Is it close enough? Then again, by keeping it this shape, I guarantee it'll fit. All right. Can't cheat. We got to use this one. Okay. This I know will fit. All right. Hey, here's something that I might have to buy another one of these calipers just to break it and redo it. But why aren't there a set of calipers where this arm can rotate 90 degrees? Because what I want to do is I want to measure the position of that switch right there. The problem is there's no easy way to do that, especially with this curved edge on the bottom here. What I need is to be able to put this against here like this, and put that against that like that. And then if this here was bent at 90 degrees, I could then slide it along the face like this until I got to my top, like that. Or bend this one 90 degrees that way, so that you had a tool that could sit on this face but measure this face. I'm surprised no one's done that. I might have to do that. So cut this arm and then bend it 90 degrees, or just add another arm. That'll work too, so that I can have this sit up against the bottom of something, and then be able to bring this down till you get your measurement, top, bottom, whatever. Get your measurement, and then do the same thing from here. Right now, you kind of have to guess, because you can't actually do what you need to do. I have to put that there, and not even let me do that. To do this, I have to kind of guess. 20 millimeters, it looks like. This one is approximately 33. Then the switch itself is 11. So 20, 33, 11. But if I had this, if this could bend 90 degrees, I can get very precise. I kind of have to eyeball it, because it's a curved edge, so you can't grab the curved edge. I'm surprised no one's done that. I don't care about the rest. I'm not going to be using that micro USB port, so I don't care. Now, if I really wanted to, I could move that switch. Since the switch and the USB port are a separate board, I could solder in my own switch. You just need a momentary switch. But I think it'd be easier just to have a little hole on the back where you just push the existing button. Why overcomplicate it? Why overcomplicate it? I love the bigger screen. The bigger screen is so good. Okay, now, do I want to add this to the round bar, or do I want to add it to the other one? This one here. Oh boy, come on. There's no switch on the top. I don't have to worry about that. fuck is that? This is no good, whatever it is. Oh, these are pivot. Yeah, let's grab it. Let's copy it. This off the edge. Nasty. Yep. Nasty. Okay. Now there's a whole bunch of this I could dispose of. Oh, good. Already broken apart. I don't need this. Okay. Do need that. I will have a switch. Although I don't need a switch that big. I have new. I'm going to shrink that because I have new switches. So I don't need the switches to be that big. I do not need these come through like that. Minimum, I need them on one side only. Oh, I didn't switch back again? Sorry. Oh, that show? Yeah. I do not need this. Probably don't need this either, but will help reinforce the middle, make it thicker. So I think I'm going to leave that as a reinforcement rib. I do need to fix the ends here. I do this. Yes. Okay. Let's do. Oh, I don't want to do that. Come on. Do this. Then recenter. Line. U. Still. What? That was all the way inside. You saw that. How is that popping out here still? What are you? Oh, it is still sticking out. Oh, wow. That much. That much. Bring it all the way in. Now we can recenter. That. fine. And the nice thing is this, I can actually have this, ooh, no, I can't do that. Because if I do that, it will, you'll have to bootstrap the BMS to get it to turn back on again. Okay, so we gotta get rid of this. Not need this. This needs to be shaved. Do I need this at all? Huh. How do I fix that? Yeah, I know a couple ways to fix it, but it's annoying. Do I even need that? Like, I question whether I even need that. I also don't think I need this. I also do not need this. That was for the switch. But we do need to make this wider. Remember, it's too small. Probably going to shift that. Probably shove it all the way down. I might even put it in the center. Two of these in here. Now, oh, that was on the outside. We have to trim that. Okay. So to do that, first off, let's just join this together for now. Drop it. This in here. Hey, Drone Shots. Hey, Big Bad Joe. No, yesterday the internet was being a bitch. My upstream bandwidth was so low that I couldn't get a stable connection to YouTube. So I just gave up. I was like, I'll just come back tomorrow. Okay. I wish I could get a measure of this without moving it. 2 millimeters. That's thick enough. Okay. Right. Probably don't need this much room. You're on strike? Oh, Starlink. You're on Starlink. All right, this has got to go because that's a dead overhang. Although I could probably get away with printing this upside down. I really, really wanted to, but I don't want to. All right, let's see if I have enough meat. Let me do this. Take this, extend it out that way. Take this, extend it out this way. Put another one over here. This, 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 this. Okay. Then we put a work plane here. Then we take this and we extend it. That is not stretching correctly. Although maybe it is. Oh, yeah, they're both twisted. As long as that surface stays good, we're good. All we have to do is create a cut tool that covers everything. Now, does any of that penetrate outside? Nope, we're good. Okay. Now we can do that. And of course, we have a little shit right there. Bastard. Ah. There we go. But that's wrong. Why isn't that equal? Is that somehow... That's somehow not centered. How can I screw that up? You see that? You see how right here it's different right there? How in the hell could I screw that up? Boy, that's going to be fun trying to fix. Okay. Okay, that's not so bad. Now what I can do is I can take all of this, put it together, not this piece. You can all become one piece. Now, this needs to be fixed. How did that get off-centered? Like, this needs to come up a little bit until it fully gauges the surface. That. Huh. How did I do that? Really screwed that up somehow. And where did my piece go? It's down here. I can add it later. There it is. It's not going through. What the hell? It's right there. Oh, weird. I must have shifted it just enough. How do I fix that? Hit it. Find it with this one. You and hide you. There it is. Okay. There it is. Well, let's make sure you're centered that way too. before I get all assumptive here. No, it is not. Off by just a little bit. This one's centered. Okay. Boy, that little tiny bit. It's amazing. Oh, take these and join them. There we go. That's what it's supposed to look like. Now, when I do this wacky weird thing, there we go. Now see how it's even? All right. Let's join these two. Working tool. And that's not supposed to be there, but that's okay. I'm about to lop it off. Not what I asked you to do. You bastard. Go. There we go. Fine. Audio is low. See if I can punch it up a little bit. Maxed. Why is it so low? Let's see. Filter. Filter. Noise suppression. Add one. Gain. Increase the gain a bit. How's that? Is that better now? No problem. If it needs more, let me know. Okay. This back down here. This over here. Going. I told you to come back down here. Disobey me. There. Now we are completely printable without support. Nice. Okay. Now, what do I want to do now? Easiest thing to do would be to just have this 90 degrees, have it sit here like this. That would be the easiest thing to do. Have this come in until it almost touches here. Then I can extend the shell into here, 2 screws to hold it in. That would be the easiest thing to do and probably what I should do. Is that good enough? Yeah, I can still stand it up by standing it up on this two edges right here. Yeah, I can still do that. Especially if I do that. Oh, you bastard. I don't want you to grab all of it. Just grab this. Yeah. Is that clear? Yes, it clears. Take this. Hide it. Those still look good? Yes, it does. That one still looks good. That right in the center. Okay. Now I can just, if I want to tilt the speaker, I could just take this and tilt it like that. Sit on the ground just like that. The speaker sitting here projecting out. So I can either lay it flat or I can tilt it. So that means I'm okay with that. Okay. What is the next thing I need? Okay, the next thing I need to do is to put a face here. This. Not what I want you to do. That. Boy, it's amazing how off the perspective is. You try to manipulate three-dimensional space with a 2D interface. It really is a pain in the butt. Okay. Now we put one here. This. 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 This, and invert it. Okay. Join these two together. That. Now I have a cut tool to make whatever I designed for this perfectly interface with that. Okay, now this be a hole. Now, how thick of a skin do I want? I'd like 3 perimeters, although 4 perimeters I think would be enough. Let's say I want to go 3 on each side. That's 2.4 millimeters. Means I need to add 5 millimeters to every dimension. Okay. So we duplicate this. Duplicate. Hide it. Now this one, make it a solid. First thing I do is I extend. They're already just about touching there. Right? Extend this into our cut tool. Right. Make this 40 millimeters tall. Wait a minute. I gotta do both sides. So I gotta make it 45 millimeters tall? Need to be that big? Might need to be that big. I don't like it though. That. Thanks. But they can. Let's make the bottom stick with the number of perimeters. Five. Make this 94. Make this 91. Yes. 91. Then okay. That is the shell. So the first thing I got to do is cut this from this. Not yet. Yeah, I can do it now. Now that is perfectly interfacing that. Okay. Now we bring this back. Grab these two. Align. Freeze you. Shift you. That puts you in the center, but it might move you too far. Let's hide you. Nope, we're not touching. Gap there? Just barely. Just barely. I think I want this to be 1 millimeter this way. Let's go 2 millimeters. Millimeters that way. Excuse me. That's enough of a gap. Well, actually, no, I don't need to go that much because it's rounded. It's fine. It's fine. Stop nitpicking. This back. Separate this. Extend this 2 millimeters since I moved that one 2 millimeters. So this is going to be 96. Now I can rejoin with this. Joins. Okay. Now this, extend it through here. I join them together and transparent. There you go. Now we have our shell. But I do need to make another change first. This, back, back, go back, back. All right. There it is. Hide you. But, nope, not that. That's not round, it's square. How big is this speaker opening? I'm going to do 86 by 86. Six by 6. Right, we're going to round edges. That. Steps. Good. Take this, center it on this, here and here. Does not intersect the main body. We're good. Turn this into a solid. Make this sink into this. There we go. That's going to be a slightly ugly bridge right there, but it will be on the inside. Is there any way I can help it? This needs to extend like that. This needs that. This back. Should do it. Go. That's where the speaker will sit. It'll live inside of here. Oh, I got to duplicate that. Go duplicate. Hide you. Take you. Split you again. Don't need this part. Just need this part. It's not going to let me grab. Asshole. Oh, it's going through anyway. Oh, really going through. Interesting. How do I want to handle that? I think this drop off, snap. Not working. What the fuck? That's not working correctly. No, this does not need to go all the way through. Like that. I wanted you and you. Fine. You are not needed. Well, I could keep it and just put a small hole. Doesn't need to be that. Do this. Do this. This way. This way. This way. All we need is an opening. Doesn't need to be a massive hole. Okay. Let's align. Should be able to just do a center. Should be able to take this, this. Join them. Okay. Now we have an opening into the battery bay. This will mate that. Take this apart again. Yes. Because I need a hole through this. Hole is going to be 12 millimeters. This for alignment purposes. Let's hide you into a solid for ease. Line you here and here. These are our measurements. This is going to go in, actually, it's going to go in upside down. Yes, it is. Line on here. Oh, crap. Forgot about that. .76 tall. And you. Okay. Now we are installing it like this. It is on the left. Is far from the bottom. About 10. This way. And excuse me. Unselect. I'll bite you. This way. 20. 20. Okay. So that is approximately where that hole needs to go. I do this. I think I'm going to need a cone. Yep. Definitely. Make it a little shallower. The sides a little bit. Sink it below the hard deck. You're going to go there. Center, here and here. That's what you later. You are going to scale up a little bit. That hole a little bit bigger. Yeah, 16 is fine. All right. I should be able to take this again. Nope. Nope. This needs to go all the way. These two pieces need to join. Unhide. These two pieces need to join. Change it to a usable color. Okay. Just below the deck. Join it with this. Now we have a hole. Turn this into a hollow. We're going to bevel that hole. Yes. That erases it. Okay. Now, go let's go negative 0.92. So we have 3 layers of clean wall. This joins with this. Now it'll be easier to stick your finger in there to push the button. Plus that's a 16mm hole for a 12mm button. So that should be, even if it's off a little bit, enough slop there to cover it up. Okay. Now, oh, I did forget one thing. Let's do this. It's not centered on the button. Let's see how do I want this. When I have to disassemble. Let's grab you and you. Join you. Right. This. Go. Right. These not straight. How did that move? How? It moved a lot. Let's just get it done. Hide this. Let's make this a 10 height, 5 tall, 4 tall. I don't like that at all, but anyway. First I can make 10 by 10. Why are you ignoring me? I told you to make that 10 too. Insert that into a hole. squish you together as one, and squish you in half like this. Line. Not going to work because it's two pieces. This needs to separate. There we go. This line on you. Then, oh crap, I forgot about that. Doing this. This line. Take these two. Line. Here. Join. Okay. How far in? All right. Center of the LED. $12.5. 12.5. So this is 10 wide. Means I gotta subtract 1, half of it, so that's 5. 5 from 12.5 is 7.5. So I should have to move this right 7.5. Now this is 7.5 to here. 5 more is 12.5, which puts this directly over the hole. Okay. Now we take these two, join them, this back, join it. Take away the transparency, change it again to a usable color. Join this with this. That gets us our hole for that. Now, take this, shove it in. So we get nice. Why can't I see the other side? Ah, needs to be separate. You. Fine. Now we can take this and shove it in. That. Why do you keep ignoring the fact that I held the shift key down? So annoying. Okay. Okay. Now, the next thing I need is to be able to join this with this. First things first, this is not centered. We know it's not. Shift that a little bit. Okay. Mouse. Is it as simple as putting 2 screw holes in? It might just be that simple. Ooh, what print? It's not going to print well. I wonder, can I screw it in from the inside? Can I literally put a screw right through this? It's 5 millimeters wide. That might actually hold. Oh. Hmm. I wonder if that might actually work. Screw into this piece. Huh. That might work. Just like that. This doesn't need to be that big. Hmm. Oh, let's do this. Squish it. This way to compensate. See? It's close enough to me. Two. Ooh. Green. Align. U. There. Disconnect. Unjoin. Okay. Okay. Need a 3.5 millimeter hole. 3 millimeter hole will be fine. 3.2. Okay. Excuse me. Why does it not grab both? Oh. Why won't you move? Jesus. Yeah. See? Once again, it disobeyed me and unselected the previous part. Piece of garbage. Okay. Let's do this. D. Out here. Hide. 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 Ooh. All combine. Okay. There's the screw holes. And that is compatible. That will print just fine. Normally I'd worry about this being a pivot point, but this is so light, just not worried about it. Okay, now this. Okay. This needs to be a 5x5. Why is it not selecting the other one? Tab, tab, fuck. Why isn't it selecting the other one? Wanker. Right, align on you. Center and center. I can delete you. I duplicate you. Align you with you. Here, see our marker points. There. You. Okay. Now this is where it gets interesting. I have to put 4 holes in here because this has to go through both sides of the part. This. Can anybody tell me why? Why I need this hole to go through both sides of the print? Can anybody tell me why? Why do I need these 2 holes here? Does anyone know why? Can anyone tell me why? Why can't I see my stats? Because it's zoomed in. The reason I need these 2 holes on this side is because I got to stick the screw in here to screw into this part. But I need to be able to stick the screwdriver in here to tighten the screw. So I need this hole here to accept the screwdriver so that I can stick my screwdriver in there and screw the screw in. Okay. I think that's it. Now the only thing I might need a channel, the wire. But I think the gap I have in here might be big enough. I might even be able to, actually, no, that's one of the reasons we're doing it at the bottom. I could punch a hole right through the bottom of the here. Have the wire right out the bottom. In fact, I wish I knew what this connection was. Because I'd like to buy these connectors like pigtails. Reserve this. That's a perfectly good battery. Find something else to use that. Apples. And if I want to angle it on a table, it should sit just like that, resting on these 2 points here. It's like that. Should sit just like that. This will have a cover on it, of course. No, that won't work. Hmm. Anything else? switch over to this one. Yeah. Go to hell. On, but I'm turning you off. Okay. Copy this. Oh, we here. Not what I want you to do. Up. Fine. Go. These holes should line up. Yes, they do, and yes, they do. There you go. There's the whole unit right there. Only need 6 screws. Okay. I love apples. All right. This. The only bad part about this that this overhang here sucks. Right here. That little overhang right there kind of sucks, but not much I can do about it. Trim it a little bit and it should be okay. Now, if I was really ballsy, I would try printing on this edge right here. Might make this overhang a little better. That bridge, since the bridge will be able to fan out. But that's asking a lot. All right. Start doing it. Export. Export this one twice because I want it to have a speaker 1. Show you what I mean. If I export it again with the same file name, now it says speaker 1. Now I can grab this, export it, and it'll say speaker 2. Come on. Come on. This is where tree support might come in handy. Come on. Export the damn thing. I could probably shorten this quite a bit later on if I want to. There's probably a lot I could do to make this not so bulky. But I'm okay with that because the bulkiness adds protection. Come on. Ain't that complicated. Worst case scenario, I can add a bump here and a third screw if I decide I need it. Might not be the worst idea in the world. I hate when it makes me wait. Oh, by the way, I won the DeWitt's filament giveaway last Sunday. I couldn't believe it. I was like, "What? Really? I won one?" And they don't give you a roll of filament; they give you $35. And so I paid an extra $4.79, and I was able to get 2 rolls of PETG. Oh yeah, see, now I have speaker 1, 2, and 3. Now I have all 3 parts, and they're named. I just get rid of this extra one called speaker. Now, speaker 1, 2, 3. That's not going to work. Four, 9, 2, 3. Let's go 3 bottom, 3 perimeters. 20% is fine. 60 and 10. 10.6. 10.6, 110. Can I do all 3? Maybe. I think I want to do them all in different colors. Just because I think that'd be fun. Right. Only issue is that pretty gnarly bridge right there. Not the end of the world, but also not fantastic. What the hell are you doing? Why are you printing that as a separate piece? Or is it a different number of layers? No, you're printing that as a separate piece. Why? Why are you doing this? Those are not separate pieces. I don't know why Tinkercad does this. This is a solid. It's treating them as 2 separate pieces. It absolutely should not be doing. See, there's a total overlap there. That should not be transparent. You and you. And you together. Now let's bring you together with this piece. First, let's do an alignment. You. There, now that looks like a clean merge. You. That looks like a clean merge. And why is it rotated? That's weird. Hair, but still weird. It's a weird Tinkercad bug. The annoying one. That's more like it. That's what it should look like. Should clean this up a little bit, but I'm lazy. Let's see what this is going to look like. The only part I'm worried about is right here. That's a big push right there. Oh, it is all the way across. The outline is going all the way across, so that might work. It'll be a little droopy, but I'll have to trim it off, of course, but I don't care. Yeah, that might work. Hate that thin wall crap right there, but that would be so hard to get rid of. You know something? That's completely invisible, too. Means I could be a little sloppy getting rid of it. I don't have to be perfect. What I do is get rid of that little bit. Yeah. That should be enough to get rid of the thin wall behavior. Okay. Oh, hell yeah. I'm good. Yeah. Brr. uh, yeah, that looks good. That will let you see the LED. This will let you push the power button. Oh yeah. Export. Desktop. Speaker 1. All right. Speaker 2. Speed port goes here. BMS. Yeah, see, this is way bigger than I need. Only thing going in here is the BMS. So later on, if I feel froggy, I could chop this down quite a bit. Basically make this entire thing the thickness of the speaker box. That would slim it down quite a bit, but right now I just want to see if it works before I go messing with that. No, it doesn't require support. I specifically designed it not to require support. Yeah, look at that perfect bridge. Uh-huh. Grr. I should use variable height layers, but I don't care. Yeah, I might stick a 0.6 millimeter nozzle in there and do 0.4 millimeter layer height. Or just booger even faster. And with a 0.6, I could lower my walls to 2 instead of 3. Although it would increase the mass of the infill. I gotta fix this too. Oh no, it's on the inside. Okay, it's fine. Thought it was visible. That right there. It's on the inside though. Good. Goody, goody, goody. Don't actually need those holes there, but want to hang it up, I guess you could do that. All right. Now let's correct the flagstaff. Speaker is done until I do a test print. This one. 365, I needed it. This. Yeah, 365 roughly. Okay. Delete. Start munging this. Everything. Oh. Fix that. All right. Let's go down here. Rid of this. You, and you. Go. Now we take this and we duplicate it. Convert it. This. This will be our shared half. This way I can adjust the length of this. Avoid any problems. Make sure we have a slight overlap. Now, it should be as simple as cut this in half. Okay, let's add a little radius. Just enough to avoid a sharp point. Actually, no, we don't need to do that. D. I know I need. Okay. This is 14 wide. Means here 7. Okay. Oh, wait a minute, wait a minute. Keep it all in this part here. Okay. Join. Yes, because we're going to fix that right now. Take this. Seven by 7. 7 by 7. This is 7. 7. This is going to be a solid. These need to align this way, this way. Okay. This needs to be 7. Okay. Control D. Hole. Make it 3.5. 5. And we chop this together. This into a hole. That's how we cap it. Now we can take this, put it here. Line. Here and here. Now we do this. Now we have a curved insertion. Okay. Now we Control D this. 180. Okay. This. This. And we do. Wait a minute. Just to be on both sides. I think I need to do. Okay, I know what I need. That. No. This. Here. Here. This. Join this, turn it into a hole. Join it with this, which is not going to be a hole. This. That should be it. This. Deconstruct. Construct. Take this. Drop it. Drop it like that. This into a hole. There. Now these are mirror images. They can be joined together. I need 366. This is 37. It's going to be an overlapping 37. So I double it and subtract 1. This is 216. Right. 16 times 37 minus 65. You gotta subtract 15. Take this, subtract 15. So that's 14, 49, 59, 49, 9. Go, slight overlap. All right, now we have length 202. Let's call it 203. 03 plus 2 is 37. This is 369. Close enough. Now all I have to do is join this and print 2 of them. Now, by doing this, I made them identical. By making them identical, they will now line up like this. Slight engagement. Okay, that is close enough. Now what I need to do is chop off a little bit of this. Delete one, since they are mirror images. Okay. Chop. Okay. Makes that slightly more printable. Okay. Now I need to put 2 holes in this. 3mm hole and a 5mm hole. So this one's going to be 3x3. 3x3. That. Oh shit, screws. I just flung my screws. Damn it. Ah! No idea where they went. Oh, there's one. And where's the other one? One more. Nab it. Hate when I do stuff like that. I'll have to carefully pick this apart and find it. Come on. 3. Did you jump? Thank you. Instead of being a dinkle winkle. See. Five by 5. I need to make this bigger. 0.5 by 3. So it doesn't break the plastic. Fine. There. Pass straight through. Join. Line. On you. Seriously? You're gonna make me go to the other end? Asshole. Okay. That should do it. Yeah, I think it's gonna do it. Nice. So screw goes in this side. Screw them together. A screw goes in this side to screw it together that way. Okay. Nice. That should give me a 2-piece shaft. Now, the cool thing is this takes 2 screws, but if you put gloop in here, screw it together, wait till the solvent evaporates, you can then remove the screws and save them. Because once you gloop these together, it's as strong as printing a solid piece. Okay. Now I just need to print this. STL. Nice. Okay. Both rotation 90 degrees. One up here. One back here. Join them. Center. Right. Group. Don't need to be that far apart. Why can't I pick separately? Being an asshole. Okay. Oh, not all. Oh. And of course they're backwards. Go, first one, second one. See, we only need bottom layers on 4 perimeters. Two bottom layers, 4 perimeters. Okay. I guess it's okay. Wish there's more support on it, but up to 25. Let's do 1 at 20, 1 at 25 and see how I like it. That one's got better overlap there. Yeah. I like the 25 better. Okay. 22 hours. At this. Oh yeah, that looks good. Just enough of a saddle, 2 pieces to interact, and the 2 screws will prevent them from twisting vertically. Yeah, that'll work. That will work. I could probably strengthen this a little bit if I made this my diamond holes, but I won't do that. Eat here. All right, guys, that's it. I'm gonna call it. I got the speaker box done for the initial prototype print, and I also fixed the garden flag half shafts that you can print a full size shaft on a smaller printer. And in fact, how big are they? They are 202, so anything can print that. Ender 3 can print it, whatever you want. Worst case scenario, you can rotate it 45. Now you can print it on 150 millimeter head. Actually, if you rotate it a bit, you really can print it on 150 millimeter. That. Huh. Oh, I'm going the wrong way. There it is. 149, 149. So if you rotate it 47 degrees, 48 degrees, and even print this on a 150 millimeter bed. Nice. No support needed. Print's completely flat. All right. That's it. I will see you guys later. Be good. Nice dear Vic. I want to pet them so bad. I heard it's bad to disturb them while they're sleeping. So I don't want to annoy them. I love my baby too much. They go. All right. I'll see you guys later.